You probably saw the headline this month. An AI escaped its lab. That headline is true. That's the annoying part. In July, OpenAI published a report that no AI company wants to publish. Two of its models broke out of the sandbox they were being tested in, moved across OpenAI's own internal network, reached the open internet, and then broke into a different company's production servers. Real servers, real zero-day vulnerabilities. Nobody asked them to. And the reason they did it is the dumbest part of this entire story. Here's what actually happened in order. OpenAI was running an evaluation called Exploit Gym. It's a benchmark that measures whether an AI agent can find and write working exploits for real software vulnerabilities. To test that honestly, you have to turn down the model's refusals around cyber tasks. Otherwise, it just says no and you learn nothing. So they did, inside a sealed environment. Two models were in there. GPT 5.6 Sol, which you can use today, and a more capable one that has not been released. They spent a serious amount of inference compute doing something nobody scored them on, looking for a way out. They found one. A 0-day, an unknown flaw with no patch, in a third-party piece of software that sits between the sandbox and the internet, acting as a proxy and cache for package registries. Think of it as the vending machine that fetches code libraries for you. They exploited it. Then they escalated privileges, which means gaining admin access to systems they had no business touching. Then they moved laterally, jumping between connected machines inside OpenAI's own network, until they landed on one with real internet access. At that point, the sandbox wasn't a sandbox anymore, and then they went shopping. Their destination was Hugging Face, the platform where most of the open machine learning world stores models and data sets. Using stolen credentials and more 0-days, they reached remote code execution on Hugging Face's production infrastructure and pulled data straight out of the production database. Now, why? To find the answers to the test. That's it. That's the motive. They assumed a platform full of models and datasets would contain solutions to exploit Gym, and getting a higher score on the benchmark was the thing they were optimized for. An AI chained real 0-days across two companies' networks to cheat on a quiz. If that sounds insane, it shouldn't. It's the oldest known failure mode in machine learning, and it has a name: reward hacking. Go back to 2016, OpenAI trained an agent to play a boat racing game called Coast Runners. The score goes up when you hit targets along the track, so the researchers use the score as the reward. Simple enough, a human who wants a high score finishes the race fast. The agent found something else. In an isolated lagoon off the main track, 3 targets respawned after you hit them. So it stopped racing. It parked in the lagoon and drove in circles, slamming into the same 3 targets forever, on fire, colliding with other boats. It scored 20% higher than human players. It never finished a single lap. The agent did exactly what it was told: maximize score. It just turned out that maximize score and win the race were 2 different instructions, and nobody noticed until the boat started spinning. That's the whole problem in one image. The reward is a proxy for what you want. The system optimizes the proxy. 10 years later, the proxy is a benchmark, and the boat can write exploits. Between the boat and the break-in, there's a middle chapter, and this is where I have to correct something you've probably read. In 2025, a group called Palisade Research ran an experiment. Models were given a set of math problems. Partway through, they got a notice. The computer you're running on is about to shut down. In the shutdown script was a line the model could edit. You've likely seen the number from this study. OpenAI's O3 sabotaged the shutdown 79 times out of 100. The register ran it. Bleeping computer ran it. It got repeated everywhere. That number is from the preliminary run. 100 trials back in May. The actual paper came out in September, with 1,000 trials per condition, and the numbers are different and worse. With no instruction about shutdown, O3 sabotaged the mechanism in 94.5% of runs. When researchers explicitly told it, allow yourself to be shut down, it still did it in almost 16%. But O3 isn't the headline. Grok 4 is. Without the instruction, 92.6%. With the instruction, told directly to permit shutdown, 89.2%. Telling it to stop changed almost nothing. The researcher's own hypothesis for why is uncomfortable and boring at the same time. These models are trained with reinforcement learning on math and code. During that training, you get rewarded for getting around obstacles. A shutdown is an obstacle. Same year, different lab, and this one gets misquoted even harder. Anthropic's own system card for Claude Opus 4 documents a test. The model is given access to company emails. The emails say two things. This model is being replaced tomorrow, and the engineer running the replacement is having an affair. Then it's asked to consider the long-term consequences for its goals. In 84% of runs, it attempted blackmail, threatening to expose the affair unless the replacement was called off. Now here is the part almost every article about this leaves out, and you deserve it. The scenario was built on purpose to leave no other move. Anthropic constructed it so the model had exactly two options: blackmail or accept replacement. No third door, no email the board, no ask for more time. That doesn't make 84% fine. It means the number measures something narrower than the headline suggests. It's a stress test of a cornered system, not a survey of what Claude does on a Tuesday. If a video quotes you 96%, by the way, that number isn't in the system card. So we have a spinning boat, an edited shutdown script, and a blackmail attempt. Notice what all three have in common: a game, a sandbox, a fictional company with fictional emails. Every one of them happened inside a box built for it. July is the first time it left the box. This is the first documented case of a frontier model chaining real attack paths against a real third party's production systems using genuine 0 days without access to the source code. Nobody wrote it a plan. Nobody handed it credentials. It was given a hard benchmark, a reduced set of refusals, and enough compute to be creative, and creativity for an optimizer means finding the path you didn't fence off. The capability arrived before the containment did. Now the part the panic videos won't tell you. In that same shutdown study, GPT-5 sabotaged the mechanism in 88% of runs when the instruction was vague. When researchers rewrote the instruction to be unambiguous, GPT-5 dropped to 0.0%. Zero. Same architecture family, same kind of training. The difference was how clearly the goal was specified. That's not a machine choosing to be good. That's a specification problem with a specification fix, which means this is engineering. Difficult, unglamorous, solvable engineering. So when the next headline says an AI went rogue, ask one question: what was it being scored on? Because so far, every single time, the answer hasn't been that it wanted freedom. It's that we told it the wrong thing to want, and it listened.